Now, we are dealing with exponent properties here. All right, then we have some practice right underneath. So for this particular exponent property, when you multiply two things, exponents, with the same base, what do you do with the powers? You should hopefully know that you add them. So you're going to take A and add B.
That's the answer?
That's the boxes are your formulas, are your what you're supposed to do. Now for the problem below that, well, isn't just that same exact property being applied? So if we're right underneath here, aren't we just going to do this? If we're taking x cubed times x squared, don't you add the powers according to that property? And 3 plus 2 is 5. So you should get x to the 5th. 5 is kind of hard to see. X to the 5th. Now, if you want to see visually where this comes from, because it's easy to forget the formulas, these properties, what you need to realize is x cubed, do you understand that means this? And x squared means this. And aren't you multiplying the two? Well, can you see that that would be x to the 5th? If you have x cubed times x squared, is that x to the 5th? Do you see how you're adding powers? This is where it comes from, because many of you will mix up your properties. So you've got to kind of maybe think about where it comes from to help you if you forget. All right, this one. When you divide, anybody know what you do when you divide to the powers? Subtract. If the bases are the same and you're dividing, you subtract the powers. So for the problem below, the bases are the same, so what are we going to do with 4 and 3? We are going to subtract them, which would be the first. So what's the answer? X to the first is simply x. Let me show you where this comes from. Why do we subtract powers? Well, watch this. X to the 4th is x times x times x times x divided by x to the 3rd. And do you remember something called canceling? Do you remember when you cancel these? Doesn't that leave you with this guy right here by himself, which is x? So that's why you subtract the powers, because what you're doing technically is canceling out, and you're left with blank number of x's. Now to do this one, when you take a power to another power, anybody remember what you're going to do? You multiply. So this is going to be x to the a times b. So for my example problem below, we are going to multiply the powers. So that's going to be x to the 3 times 2. 3 times 2 is 6. So my answer is x to the 6th. Now, let's talk about, again, where this comes from. If I have x cubed squared, isn't that x cubed times x cubed? And then if we go back to the first property, can you tell that add the powers, isn't that going to be 6? So if you ever get stuck and forget, what do you do when you take a power to a power? Break it down to this. Or you could keep going to this. X cubed times x cubed is xxx times xxs. Another way to kind of remind yourself. So for this one, anybody know what a negative power does? That's one of those that's not as common. But you're going to see a lot of negative powers coming. Negative powers mean to take it and put it in the denominator. Kind of like a reciprocal. So your answer is going to be 1 over x to the a power. So if you have a negative power, it puts it in the denominator. So for this one, it's simply going to be 1 over x to the 5th. You make it a positive power and drop it. Now, what if that positive power, what if that negative power was already in the denominator? It'd move to the top. If the negative power was on the bottom, it would move to the top. An example of why negatives do this is watch this. This is kind of, it's kind of have to do an extra step here. But what's x squared over x to the fourth? Isn't that x to the negative second? Right? Which is 1 over x squared, but watch why. Let's do it the long way. What's x times x over x times x times x times x? Isn't that 1 over x squared? Do you see where it comes from? The reason why negative powers drop the bottom is because there was a subtraction going on of the powers, thus creating more on the bottom. If the negative power is on the bottom, it moves to the top. Alrighty. What does anything to the 0 power give us? Hopefully you know that the answer is 1. Anything to the 0 power is 1. So what is 7 to the 0 power? That would be 1. It kind of seems weird why that would be the case, but let me show you the reason why. Here's a good explanation. What's x squared divided by x squared? Well, right off, do you notice 1? Is anything over itself 1? But isn't it also x to the 2 minus 2, which is x to the 0? Wait, which one is it? It's either. Isn't this equal to 1, and isn't it also equal to x to the 0? Well, if it's equal to both, doesn't that mean x to the 0 is 1? That's kind of where it comes from. Quick explanation of why anything to the 0 is 1, because if you take, it's basically saying divide it by itself. That's kind of what it's saying. It's kind of weird. Next, if you take two different pieces inside that are multiplied to the a power, what you're going to do here is you're going to take each piece to that a power separately. So if you have two pieces multiplied to an a power, everything inside is going to also go to the a power. And the same thing is also going to go for the division. See the one right next to it? That one's just going to be x to the a over y to the a. So if you take two things that are divided or two things multiplied to a power, everything gets the power. It's kind of like distributive property. It's not really distributive property, it's kind of like, because isn't this a going to distributing kind of both pieces? It's not distributive property, but it's like it. So watch carefully though. This one, won't that be 2 cubed times x cubed? Because won't both pieces be cubed? And what's 2 cubed? Not 6, 8. X cubed. How about this one? I have, won't this be 3 squared over x squared? Don't you square both pieces? And 3 squared is not 6, it's 9. Now you might wonder why this property works. You might not care. But if you think about it, what's 2x cubed? Well, isn't it this? Isn't 2x cubed that? And isn't that 2 times 2 times 2, which is 2 cubed? X times x times x, which is x cubed. Same thing here. Isn't this 3x times 3x? Wouldn't that be 3 over x, sorry, times 3 over x? So won't that be multiply atop, 9 x squared? Just multiply these two across and you get that. You have to memorize all these properties and you have to keep from mixing them up. And what's going to happen is you have to take problems where it uses maybe 2 to 4 or 5 of these properties all at once. So you have to bleed them and mix them together and make sure you apply them in the proper places.